Welcome again, students. Hope all of you are in good health. Today we will start with another chapter of science, that is chapter 12, Light, Shadows and Reflections. So in this chapter we will study about what is light and what are its sources, different types of materials which transmit light differently. Then we will study about rectilinear propagation of light, about shadow in the different conditions essential for its formation, and also different characteristics of shadow. And in the last, we will study about pinhole camera and how the image is formed by it, and also mirror and reflection of light. So let us start with the light first. Now, what is light? Students, light is a form of energy which enables us to see our surroundings in the most effective way. Although light itself is invisible, but it makes things visible to us. And this energy which we receive from light is important for the existence of life on the earth. For example, you all know that green plants prepare food by photosynthesis with the help of energy of light and give out oxygen that we breathe. So you can say that light is important for the existence of all living things. Okay, now what are the sources of light? Or what do you mean by sources of light? So the objects that give out light, those objects are called sources of light. Now they can be either natural or artificial, or you can say man-made. Now the natural sources are the sources of light that occur in nature. For example, sun, stars, fireflies, etc. While the sources of light which have been made by humans are called man-made or artificial sources of light. For example, electric bulb, candle, torch, etc. Now, these natural and artificial sources are of two types, and these are luminous and non-luminous. Now, what are luminous? Students, certain objects in our surroundings which emit light of their own, these objects are referred to as luminous objects. For example, sun, stars, bulbs, tube lights, firefly, etc. While on the other hand, some objects do not emit light on their own. Such objects are called non-luminous objects. These objects become visible to us only when light falls on it from a luminous object. For example, moon, book, tree, table, chair, etc. Okay? Now students, you know that the different types of materials transmit light differently, and based on the way they transmit light, materials can be divided into three types, and these are transparent, translucent and opaque. Now let us study about them. Transparent materials are the materials that allow light to pass through them, due to which we see things clearly through them. For example, clear glass, clean air, clean water, cellophane sheet. These are few of the examples of transparent materials. Now, translucent materials are the materials which allow only some of the light to pass through them. We cannot see clearly through these materials. For example, grounded glass, butter paper, tissue paper, etc. are the examples of translucent materials. Now, opaque materials. Opaque materials are the materials which do not allow any light to pass through them, due to which we cannot see anything through them. For example, wood, metals, clay, brick, wall, book, etc. Now next is rectilinear propagation of light. Students, observe the light entering a dark room through a small hole in picture A. You will see that light appears traveling in a straight line, and this property of light to travel in a straight line is called the rectilinear propagation of light. Let us make it clear with another picture. In picture B, when the rubber tube is straight, you see the candle flame through it. But when the rubber tube is bent, the light of the candle flame fails to reach us. Therefore, we cannot see the candle flame. Thus, we can say that light travels in a straight line. Now, students, this rectilinear motion of light can be represented by a ray and a beam. Now, what is a ray and a beam? Ray is a line with an arrow, and this arrow shows the direction in which the light is traveling. You can see in figure A. Figure A represents a ray of light, and the arrow shows the direction in which the light is traveling, while beam is a collection of rays. And when the rays of light travel parallel to each other, then the collection of such rays is called parallel beam of light. You can see this in figure B. So these are the parallel beam of light. Now, when a beam of rays start from a point and travel in various directions, then the collection of such rays is called divergent beam of light. Like you can see in figure C, these beam of rays, they are coming from a point source of light and they are traveling in the various directions. So such beam of rays, they are called the divergent beam. Okay. Now we will study about shadow. So what is a shadow and how it is formed? Students, shadow is a dark space formed behind an opaque object when it blocks light from any source of light. You can see in the picture also that when an opaque object is placed in the path of light, it stops light from passing through. And since you know that light travels in a straight line, so it cannot bend around the opaque object. So it cannot light up the space behind the object. And this is how a shadow is formed. So what is a shadow? Shadow is a dark space formed behind an opaque object when light is blocked by the object. Okay. Now, what are the conditions usually needed for the formation of a shadow? So the conditions which we need or which are essential for the formation of a shadow are: we need a source of light, then there should be an opaque object to obstruct the path of light, and also we need an opaque screen behind the object. Now students, what is a screen? Screen is any surface on which a shadow falls. Okay? Now let us look at the different characteristics of a shadow. Students, the shadow is always dark regardless of the color of the object. No matter what the color of the object, the color of the shadow cast by it is always dark. So you can say that the shadow is always dark. Now the next characteristic is the shadow shows only the outline or the shape of the object. No details of the object can be seen in the shadow. Okay, we can only able to see the outline or the shape. Now the next is it is formed in the direction opposite to the source of light. Now this you can also able to see in the given picture, that the shadow of tree is formed in the direction opposite to the sun. So you can say that the shadow formed in the direction opposite to the light source. Now the next characteristic is the size of a shadow changes with the distance between the light source and the screen and the distance between the object and the source of light. The distance between the light source and the screen and the distance between the object and the light source changes the size of a shadow. Okay? Now the last is the shape and size of the shadow also varies with the position of the source of light. You can see this also in the given picture, that the length of a shadow of a tree changes with change in the position of the sun. So you can say that the shape and size of the shadow also change with the position of the source of light. Okay? Now students, sometimes shadows can also mislead us about the shape of the object. You can use your fingers to form interesting shadows resembling the shapes of animals and birds on the wall or on the screen of a dark room by using a light source. Now next is eclipses. Students, shadow formation takes place in nature also. The earth and moon also cast their shadows when sunlight falls on them. So you can say that shadow plays an important role in the occurrence of eclipse. When the sun, the moon and the earth are in straight line with the moon in the center, in that condition, the moon blocks the light of the sun from reaching the earth. Thus, the shadow of the moon is formed on the earth. Hence, the sun will not be visible from that part of the earth, and this is called solar eclipse. While when the sun, the earth and the moon lie in a straight line with the earth in the center, In this case, the earth blocks the light of the sun from reaching the moon. Thus, the shadow of the earth is formed on the moon, thereby blocking the sunlight on the moon, and this is called lunar eclipse. So you can say that shadow formation also take place in nature, and shadow also play an important role in the occurrence of eclipses. Now what is a pinhole camera? Students, a pinhole camera is a simple camera without a lens but with a tiny pinhole in one side. It forms an image of an object on a translucent screen. And you know it works on the principle that light travels in a straight line. Or you can say the rectilinear propagation of light. Now this pinhole camera is used to capture the movement of the sun. As you all know that it is very harmful and damaging to our eyes to view the sun directly. So we use this pinhole camera to see the movement of the sun. This pinhole camera also be used to view a solar eclipse. Now students, you can see this pinhole camera in nature also. If you observed, sometimes the gap between the leaves of a tree act as a pinhole camera and form an image of the sun on the ground. Hence, we can see small circular disc on the ground under a tree during daytime. Now let us make a pinhole camera. Students, for this we need a medium-sized cardboard box, or you can take a shoe box also, and color the inside of the box with black color. Now with the help of a needle or a pin, make a tiny hole or a pinhole on one side of the cardboard box. After this, cut out a rectangular portion of the side of the cardboard box opposite to the one on which the pinhole was made. Then cover this rectangular hole with butter paper or any translucent sheet. Stick the sheet with adhesive tape, as the sheet serves as a screen. And see, our pinhole camera is ready to see the image. Now let us see how image is formed by a pinhole camera. For this, students, just look at the given picture. You can see that the light from the upper point X of the candle flame passes through the pinhole and strike the translucent sheet at X dash. Similarly, light from the lower point Y of the wick passes through the pinhole and strike the translucent sheet at Y dash. When light from all other points which are between X and Y passes through the pinhole, they strike the translucent sheet in between X dash and Y dash. Hence, an inverted and small image is formed on the screen. So with this, we can say that the image formed by pinhole camera is inverted and small. The image is not too bright, and also the image is of the same color as the object. Okay? Now we will study about mirror and reflection of light. Students, We all use mirrors at home. We look at the mirror and see our image in it, isn't it? You know, this is due to the reflection of light. Now, what is reflection? When a ray of light falls on any surface, it changes its direction and bounces back. And this bouncing back of light is called reflection. Now, the ray of light which falls on the reflecting surface of the mirror is called the incident ray, and the ray of light which is sent back from the surface of the mirror is called reflected ray. Okay, so the ray of light which falls on the mirror, that is called the incident ray, and the ray of light which is sent back from the mirror, that is called reflected ray. Now, in the given picture, you can observe that the light rays which were coming straight from the comb, that are the incident rays, which were coming straight from the comb, are reflected by the mirror is also in a straight line. Okay? Now, types of reflection. Students, based on the surface from where light is reflected, reflection can be classified as regular reflection and irregular reflection. Now, the reflection that takes place on a regular and smooth surface is known as regular reflection. In this case, the reflected light moves only in a fixed direction. We get to see clear images due to regular reflection. For example, in case of a plane mirror. In plane mirror on a regular and smooth surface, we get a clear image. While reflection that takes place through a rough and dull surface is known as irregular reflection. In this case, the surface reflects the light in different directions. We get to see blurred images in case of irregular reflection. For example, reflection from water. Now next is lateral inversion. Students, when we look at ourselves in the mirror, we see our own image in it. Our image formed in the mirror is of the same size and at the same distance from the mirror as we are standing, isn't it? However, the right and left of the object and its image are interchanged. For example, if you stand before a mirror and raise your left hand, what do you observe? You see that it appears in the mirror that you are raising your right hand, isn't it? So, this left-right reversal of an object and its mirror image is called lateral inversion. Now, the property of lateral inversion is also used in writing the word ambulance on vehicles that carry patients to hospitals. This is done so that the driver in other vehicles ahead of the ambulance can easily spot the word ambulance clearly in their rear view mirror and can immediately give it the way. Okay. Now at the end, let us see the comparison of shadow and an image. Students, you know the similarity between a shadow and an image is that neither of them can exist without light. Both shadows and images need a screen to form. However, there are some differences between shadows and images that are being listed in the given table. So let us see these differences. Now the first is color. You know, image is of the same color as the object, while shadow is always black in color, or you can say that it is always dark in color. Next, image shows all the details of the object, while shadow does not show all the details of the object. It only tells us the shape of the object. Next is lateral inversion. You know that image undergoes lateral inversion, while shadows does not undergo lateral inversion. Then image is formed when light from a source bounces off a surface and reaches our eyes, while shadow is formed when light is blocked by an opaque object. And the size of the image is same as the object, while the size of the shadow depends on the distance between object and source of light and distance between object and the screen. Okay. Now, with the wrapping of this chapter, I hope all of you are able to understand the topics which we have covered in this tutorial.